Well,
It's better.
you know, the more the complicated the problem is, the better the
So,
technician is going to be after you solve.
so one problem I said, yesterday I got one laptop. It is charging sometimes.
Hmm.
So when I change the charger, it is working fine and the battery goes to 100%. So I
Okay.
think, oh, it's a problem with PSID. So I said to the customer, oh, it's a problem with the adapter.
Okay.
So buy
Okay.
new adapter. So he said, okay, just buy it. So I bought it from other shop, and after second time I'm inserting, it is not plugged in, not charging.
Okay.
So after I removed it and connect other charger, it is working fine. So I changed the battery also.
Oh crap. Okay.
So when I'm checking for PSID for the data and clock, it is showing 3.3 volt.
Okay.
So with DSO, I don't know how to check it. So I leave it. And after 5-10 minutes, I check for the data and clock. It is showing 5 volt.
Eh?
At so how it is possible? 5 volt is coming from that IO. So I thought it's a problem with IO. I bought IO, but I did not fix it. I changed
Okay.
it and I will tell the result.
No, it's sometimes what happens. Sometimes was that IO programmable or it has an EC BIOS?
No, it's not programmable IO.
So sometimes it's a problem of EC BIOS as well. Okay. I can
Okay.
share you a video on my channel as well. There was a charging problem that was solved with the EC BIOS programming. Okay. So sometimes that also is a problem with the charging section. Okay.
But
And
how 5 volt is coming on that
it can come.
data?
It depends upon. It depends how it is. IO is programmed. How IO is programmed. Sometimes you will see 1.5 volt coming from the SAS supply. Okay. The SAS on, it was coming 1.5 volt, but it was not it is not the actual voltage of the SAS on. It is 3.3 should be coming, right? But it was coming 1.5 volt. How is it possible? Because it directly comes from the IO. Okay. But in this case, where do you check that voltage? At the terminal, at the pull-up at the pull-up register.
Terminal only. Terminal.
There are two terminals of the register. One is the pull-up out input and the one is pull-up output. Where is the SDSL connector? See here. This is the pull-up register, right? This is 3.3 volt. This is your SDA line, right? Or SCL line, right? You checked here or you checked here?
I checked at the battery terminal, sir.
At the battery
So
terminal.
sometimes, yes,
No.
sometimes in the battery terminal it is showing 3.3. At that time it is working perfectly.
Yeah, it means what? It means what? Somewhere this voltage is having a problem from some external circuit. It is getting supply from 5 volt. Remember one thing, either 3.3 volt or 5 volt, it will work fine. No problem with the SDSCL. It has a limit. It has a limit of 1.8 volt to 5 volt. It can work within this limit. SDSCL will work within this limit. 5 volt, I have used it. I can give you a video where I have used 3 volt 5 volt IC. In place of that, I have used 5 volt IC, working fine, no problem with this. In place of 3.3 volt, I have used 5 volt also. SDSCL also goes from there only, no problem with that. So it's not that issue of voltage. It's an issue of data that was not going properly to that. It's an issue of data. Did you check this resistor value, how much it was coming?
I will check it tomorrow. I
No,
removed
you need to check
that
this.
IO
This is a
also.
10 ohm resistor. Okay, this is a 10 ohm resistor. A very sensitive value. It's and it's a 1% tolerance. We'll discuss all these things when we come to the charging section. So this will allow what if its value increases, then the current injected into the SD and SCL will be low. And the IO will not get all the information of the battery, and your plug-in not charging message will come when you see in the battery. Okay, we'll come to all those problems later on when we go into the charging section. You can see that. So we'll stuck to this problem now. This was it was coming approximately 104 milliamps sometimes. It means my board was getting on up to some sections. Okay, and in there I was getting 3.3 volt was okay, 5 volt was okay, RAM voltage was okay, core voltage was not coming, and run on. There was two supplies, SAS on, and one is what, run on. SAS on was coming. You can't hear me?
I guess so.
It's differences there. Sorry, brother. I don't know. Is it my or your? I don't know.
Am I audible now?
Yes, of course. But you have these interruptions.
Now is it clear?
Yes, yes.
It's clear
And
for
time,
me.
yes. Yes, yes, yes.
Okay, okay. It was coming to all
Okay.
of you. It was coming to all of you.
Yes.
No, sir.
Okay,
Okay,
it might
maybe
be for
something
the
on my line.
it might be
Maybe
for
it's,
the international students only.
maybe I have
Okay, no
some
issues.
problem. I
No
don't know.
issues. No
Okay,
issues.
okay,
No issues. Now it's okay now.
okay.
Now it's fine.
Yes, yes. I can
Yeah.
hear you clear.
Right, right.
Really clear.
So
Good.
this is what SUS-on supply and this is run-on supply. These two supplies are there, right? This is a S5 supply. This is what? This is S3. Okay. Sometimes it is changed to S0 also. It's interchangeable, right? So this SUS-on was coming. This run-on was not coming from EIO. I'll open the schematic now. I can't explain it like this only. I have to go to the schematic as well. I've opened that schematic here and I'll search what SUS-on. See here where it is coming. This is the SUS-on, right? Let me search it again. It's coming from where? IO?
Yes.
It's IO? IT?
Yes, yes, yes.
So it is coming from
8510.
IO, 100 number pin, right? And I also remember the pin of the run-on. It was 123 number pin. So search 123 number pin, it was run-on. Where it was, I think it was this, here it is. This 123. It's what? Run-on. This is the run-on.
Oh,
Okay.
yes, yes.
My run-on supply was not getting on. Okay, but my SUS-on was available. My SUS-on supply was available, but my run-on supply was not available. Now let me search it.
Run on. Run on one. Okay. One question,
Yeah, yeah.
Dildar. Here on the left side, the pin 100 to A105. On the left side, what is this LPC FVH
Yeah.
flash?
This is a
what
low
this section?
low pin count. It's a low pin count. Okay. This is used for where the same
Yeah.
pin, the same number of pins can be used for different purposes. Okay. It's for what? Embedded controllers only. It's for embedded systems only, and you cannot use for you cannot connect a hardware system to that. Okay, in GPIO what happens, you can connect anything, a peripheral device to the GPIO pins, but to the LPC pins it's a specific, it works on a data basis. Okay, it has internal programming with that. 8051 programmer microcontroller inside it that programs the working of this LPC and all the sections of the IO. That will be covered in description by Nasir sir. Don't worry about that. But here you asked me, so I told I need to tell you. It's an LPC section. It's a low pin count. It works with 33 megahertz. Okay, you'll have 33 megahertz frequency here. Okay, and it's a communication with what? BIOS. See here, it's an EC BIOS communication. EC flash SPI.
SPI,
flash, okay?
SPI, yes,
Yeah.
this flash, yes.
So,
BIOS.
yeah, it's a
yes.
flash. It's been BIOS. So it's a BIOS communication. It's a 33 megahertz communication between BIOS and IO. Okay. This will only be triggered after handshake signal is given by the PCH. Okay, you'll understand all those sequencing when Nasir sir will tell you. Okay.
Yes, because
Yeah.
PCH controls.
Right.
Yes.
Now I'll go for the run section. Run underscore on.
It's gone on underscore one.
One is, I think it's not taking. See here,
okay.
it's at the
Okay.
rate, it's a star here. This is the run on coming here. Okay, it's a run on. When it's 1.8 volts, I told you 1.8 was available.
Yes.
So 1.8 power grid was also available. So this is an AND gate. So this signal was not coming. Okay, and it's an it's a star. So this resistor is not connected. So it is not directly going here. Okay, so it needs both the input to be high so that you can have run on supply here, right? And now this run on is going where? See here, this run on is going to turn this 1.5 volt run supply. Okay, this is what going to
Yes.
enable
yes,
the,
chip.
this is going to enable the 1.5 volt run supply, right?
Mm.
Now let's go on where it is going to enable also the your VCCP 1.05 PCH supply, right? All the S0 state is going to be enabled here. It is going to run on is coming here, going to enable this RAM IC. I was also not getting this VTT voltage. Okay, let's go
VTTS.
where it is also
Right.
going somewhere else. It is going to my BIOS also. No, it's not a BIOS. It's our 1.25 run, us another run supply. Let's see once again. Yes, I was expecting this. I was expecting that either this MOSFET or this MOSFET was faulty. I was expecting this because this is the signal that is going to change this run supply. After this run supply is over, or it is possible that when this MOSFET is shorted, this can ground this run supply. Okay, or it means if it is leakage, 1.5 volt supply may come here. So this supply was here, not here. So, and these two MOSFETs are working fine. These two MOSFETs were working fine, no problem with that. Now what you have to do, you have to the option of what, removing that resistor from where it was coming. Go back. How you will check? You will remove this resistor.
Put a wire.
Yeah,
But it is in star mark.
Jump.
no problem. Let me see. Somewhere it will be having a resistor because I checked it, so I know. I removed that resistor. Okay.
0.0.
Yeah.
0.5. Run on one, also 2.
Yeah.
Discharge. So run on where FTS.
No, so let me see once again. It was there on the board, but sometimes this schematic, I don't believe this is schematic. Sometimes it was there on the board. So what I did was there. I'll tell you the my experience. It will. I'll put that on YouTube as well, but it will take time. So editing is a big task because we also talk when we solve the case. So I need to remove those talkings. So see here what I did. I'll go to the 123 pin of the ITE. Yes, what I did was there was a resistor here. After this there was a resistor. I cut this supply from here. From this point, I cut it off. So I can isolate that whether this run supply was getting down due to my IO or it was getting down due to my external circuit, so that I can identify which circuit was my problem. Okay, so when I cut it down, still I was not getting this run on supply. So where is the problem? IO? IO is the problem?
Yes. I support yes.
I removed the IO, I replaced the IO, still same problem. Now what you will do?
A little resistor something somewhere, I don't know, brother.
Okay. So
Did you
any,
put, just a moment, please.
yeah.
Have you put some voltage injection there?
Yes, I tried that as well. I cut this supply from here and I put 3.3 volt supply on this run. But my
Very good.
my board was not getting on.
Oh.
Now then what I have to do?
Hmm.
What you will do? You return the board, you change the board. Replace 2 to 3 IO.
No.
See now, what was exceptional was I was not coming to the basic. My fault. What my fault was, I was not coming from the basic. The basic thing, because this board was not turning on, sometimes turning on, sometimes not turning on. So the most basic thing is the RTC section. The most basic thing is the RTC section. You have to go back to the RTC section. Then I just went back to the basics and just go to the RTC section. See now RTC. So RTC cell voltage was coming fine. It was 2.8 volt. All the supplies were okay. No problem with that. problem was where where's the crystal? The problem was with the crystal. Okay, I gave you this one. This is the crystal. This is the crystal. So this x1 is the input, this x2 is the output, right? So this one was good, but this one was not coming. This one was good, but it was not coming here. Okay, and there's a 10 mega ohm resistor here. You always check at the terminal of this 10 mega ohm. One is the input, one is the output. Okay, so this one was okay. This one is okay. It means what? My PCH is okay. This one is okay means what? My PCH is okay, because it is coming from the PCH and then it is going out from the X2. Okay, it is going out from the X2. So it is coming from PCH. It means my PCH was okay. Then what I did, just remove this one and put another crystal. It was working fine. But the question, my question was, how sus on was coming? How system on sus on was coming? IO had not all the requirements, but still sus on was coming. You have not gone through the IO requirements, all the what are the requirements of IO, so you will not understand the curiosity of this problem. When you go through all those things, then you watch the video, then you will understand that all the requirements are not fulfilled, still sus on is coming out. How is it possible? Okay, so sometimes there is a mysterious problem as well. I didn't understand still what was the problem, but by changing this crystal, the problem was solved. But I'm still finding out why it was not, why sus on was coming out, because it was S5 state supply, and it will only come when you have all the requirements of IO fulfilled. Okay, so let me go to the power sequence if it has some.
One more question.
Yeah.
Is there any specific way to check the crystal is working or not? Any secrets to check this crystal is working or not?
Yeah, I have
Very good question. Thanks.
I have a secret machine for this. I'll tell you
DSO?
that. DSO is
Oscilloscope is your friend.
Yeah.
No good. No
That-
good.
just grab him. That is if somebody asks me which is the means magical tool so that I can find all solutions, I tell him I have a magical tool. Go for DSO. You'll find everything there. Okay, when you get the DSO video, we have put a lot of effort into that. You'll understand all the things. Okay, we have put a lot of effort into making those videos. You'll get that.
By the multimeter, we can't able to check this crystal is working or not. Is there any way to check them with multimeter?
No, you have to put more money into the problem.
Okay, see. Can you understand my Hindi without translation?
Very hard.
If I start speaking in Hindi, will you understand? No, you don't understand.
No.
Then how can you expect multimeter to understand the frequency?
Senthil,
No. Actually, what I come to say is my previous
some-
bad experience was like that. So many
Yeah,
cases.
sometimes you see what you will see 1.2 volt 1.3 volt supply in that
Yes.
in at the crystal, then you can assume that it is coming good, but that is not a fixed thing. There could be some
Okay.
glitches. See here,
yeah,
there could be some glitches. See here, what I wanted to explain you, because it's a my personal experience I have. See, so this is a sinusoidal wave that comes here. You'll see the 32 kilohertz sinusoidal wave. Okay, it's 32 kilohertz, 32.768. Right. I'll tell you a way to understand which is the input, which is the output. At the input, you will have a lesser peak to peak value. This is a peak to peak value. This is a peak. This is another peak. Peak to peak value is low, then it is input. When you have a bit extra peak, a peak to peak value higher than that one, then this is what output. This will help you when there is no schematic and there is no board view. Okay. Then how will you understand this is the input or this is the input? So you have to understand by this that when this amplitude is a bit lower and the output amplitude is a bit greater.
Right.
Okay, if say it is 1.2 volt, it will be around 1.5 volt. Okay, so this is the difference between the input and the output. This is how you have to determine it. right? So if you check it by multimeter, you see only this 1.2 volt, sometime going down, sometime going up, fluctuating all the time. Okay, so that way you can just see the voltage of this. But if there is some glitches like this,
Okay.
so this is all this will also give you 32 kilohertz frequency. This will also give you 1.2 volt, but its shape is not that which is required by the IO.
Sir, I
Yeah.
also have a way of explaining very easily.
Yeah.
Trying to do with a multimeter, what you need an oscilloscope for is using a soldering iron for blow hot air station work.
You got his point?
No.
But Senthil, in
you
olden
cannot
days,
you cannot use soldering iron for hot air station work, right? It is not a feature of soldering iron. So when you look at oscilloscope is giving you idea in time, but multimeter gives you that second. When you touch it at that second, what is the voltage? But if you put a DSO there, it's like a movie. It's like, okay, the signal was how was it before? If something happened, if something changed or not, what happened? Your multimeter is not measuring that at all.
So
sir,
yeah.
but old technicians are there checking crystal by using that analog multimeter. It is showing some deflections.
Yeah, it will show. Analog multimeter is more difficult to use. DSO is just nothing. Go for auto, you'll get everything. DSO is very easy. When you
But
go with
all
that CI,
technicians,
they are expertise. What you want? You want to save your time or you want to save your money? If you want to
After
save,
completing,
Sir, time is money.
after completing this course, please give some discounts to buy DSO with laptop.
okay, you can contact. I'll give you the number of.
No. I don't want to contact anybody.
Okay, you'll tell this to Nasir sir. He deals with all those things. I don't deal with it. Okay. You will get. Don't worry.
No, Satya, okay தானே?
ஜி
Let's.
பக்கா ஜி எனக்கு ரொம்ப ஓகே
I need a translator.
Senthil, what is your budget? How much are you expecting to pay for it?
His
Still,
budget is
I'm
for
not fixed
his budget is for MSO.
ஜி actually he's having something like 80,000
Okay.
rupees he spent for magnifier.
So then it doesn't make sense, man. Then you got to
you
buy.
don't have
Okay.
issue with you don't have issue with money.
Right. So now this was the case. Now we are done with the 3 volt 5 volt section. Now just get some extra energy and we'll start with the most interesting one, which is this charging section.